So we're going to estimate the area underneath this curve between the line and the x-axis. So here's the x-axis. By using rectangles, and this is going to help prepare you for one day if you ever go to calculus and you find the area under the curve in calculus by, of course, doing other methods. But this is the basis for doing that. So what we're going to do is break up this graph into a bunch of rectangles. And all the rectangles are going to have a width of 1 because it's really easy to do multiplication with 1. And since we're trying to find area is base times height. The base of these rectangles are all going to be 1. But, of course, because your curve is not constant, the height will change, so the area underneath the curve will change. So we're going to make a bunch of rectangles, find their areas, and add them all up. Pretty easy stuff. So we're going to make, in this case, 10 rectangles. Each of them have 1 unit wide, but we have to calculate their height. So using the right-hand method means we're going to use this side as your height. Okay, the right side. There are 2 sides to every rectangle, a left side and a right side. We're going to use the right side. So that means we draw our rectangle by going up the right side until it hits your line, and then you go back over and there's your rectangle. Okay, same thing for the next one. You go up the right side of your rectangle until it hits the line, and then you come back over and finish out your rectangle. So the right-hand method just means which of the 2 sides are you using to find the height. So in each of these, we're using where the right side touches the x, or rather the line. Thus, the right-hand method. Okay, there are lots of other methods. There's the left hand where you use the left side, and then there's the center one, the average. You can find the midpoint method. And each one of these gets more and more accurate because of the way that we estimate. So if we added up all these things, well, let's just do some calculations. The area of the first black rectangle has a height of 1, 2, 3, 4.5. So this must mean it has an area of 4.5. Okay, one of the conveniences of using a width of 1 is that we only have to take one measurement and multiply that by 1, and that gives you the area. Pretty stinking easy. So this next one has an area of 5 because the right hand goes up to 5. And then this will be, of course, 5.5 because that's the y value right here, 5.5. And then the green one is up here at 6. And then the yellow one is up here at 6.5. So all we're doing is we're counting 5, 6. We're counting vertically the y distances until we get to that line. And we're making a rectangle, and we are calculating the area by multiplying it by 1. Super simple calculations. There's 7. And then this next one will be 7.5 because that's the height. And then this next one will be 8. 1, 2, 3, 4, 5, 6, 7, 8. So we're finding the area of each of these rectangles, and then we're going to add them up. Yes, very tedious, I know. And in calculus, don't worry, it's not as tedious. There's a formula to do all of this. We're just doing it because we're not in calculus. So if we add up all these heights, 4.5 plus 5 plus 5.5 plus 6 plus 6.5 plus 7 plus 7.5 plus 8 plus 8.5 plus 9, we get 67.5 square units as the estimated area under the curve. So we can ask, is this going to be an overestimation or an underestimation? And the answer is probably over, because we have all of this extra area on each of these rectangles that isn't actually underneath the curve. So this is definitely an overestimation for this one right here.